Are there lessons from Ukraine that traditional defense and commercial companies are ignoring, but perhaps shouldn't?
I think one of the craziest things we see is how many American products have a very short shelf life over there. So what we need to actually do is think about interoperability and truly adhering to modular architectures when it comes to both hardware and software. It's something we've been really bad within the United States doing. Vendor lock is a real thing. We have to break that, and we have to build stuff that'll interoperate. Or I'll give you an example. Say you have a really nice radio on your drone, and we're not fighting, the Taliban or ISIS anymore. We're fighting armies of PhDs, right? So when they learn how to jam your radio, your thing is now dead. You have to be able to hot swap a new radio or comms link in without rebuilding the entire electrical architecture of the drone. And that's just kind of antithetical to how we've built and designed stuff. We've done more exquisite things where we'd always be in control and not, fighting a near peer.
And so how should that impact, I guess, the way, or maybe it would be helpful to give a little context on Firestorm, and how has that informed the way you think about building manufacturing capacity?
Yeah, so I'll just back up. I started a counter-UAS company for sports stadiums in 2015. The Navy SEALs found it, took it to Iraq. We were the second system in there. We worked hand in hand with them. We ended up selling it to Blue Halo. The product now lives at AeroVironment. It's called the Titan. But I always had a lot of appreciation for how well ISIS was able to use attritable systems, and at the time they're mainly DJIs they were modifying, to literally fight the United States to a standstill in Iraq and Syria. And so our vision was, how do we replicate that? And it started kind of with a rethinking of the art of the possible. We don't have a lot of carbon fiber in our drone. We actually don't even do a lot of injection molding. We use big industrial 3D printers. So our partner is HP. And what we've figured out here is that you can kind of design for things to come out of these printers in a way in which you can kind of infinitely scale them. And because there's networks of these printers around the world, you can almost Amazon, on demand, all the parts that are taking hundreds of hours to kind of lay up or put together in a way where we're doing kind of a just-in-time assembly, and it takes us less than 10 hours to build a big Group 2 drone, which is really fast. Now we're putting those in 20-foot containers and moving them around the battlefield. And so that's how we think we're going to help solve the problem. Contested logistics and building things at the point of need is a massive issue, especially as we look to the Pacific. And we think there's a really compelling story, too, for decentralized manufacturing. So lots of these micro factories spitting out stuff within a very good tolerance that allows you to put initially thousands and then tens of thousands and eventually, hopefully, hundreds of thousands of systems into the battlefield.
Maybe, Keith, then it would be great to get your perspective. You're at Anduril, it's a new prime, but you built your career in automotive at Toyota and Tesla prior to jumping into defense. So you're currently leading manufacturing at a company that's building systems for defense and war. What lessons from building an automotive and that sort of that way of building out a supply chain are you applying at Anduril?
I think one of it is just really understanding the problem. Like what Dan talked through is to basically say, to build at these volumes, like the techniques that we have, all of these things don't solve. And the fact is, it's not about taking the exquisite hardware we have today and then saying, oh, wait a second, how do I solve this at the scales of hundreds and thousands? Like, it literally does not. And so it's like, how do you take those learnings and the understanding of what it's really going to take at these volumes and integrate that as we're talking about the products, as we're making these trades, as we go do these things? Because once the product is locked, and people talk about design for manufacturing, if you're doing it at the tail end, it's nothing more than sanding corners. That's really the amount of opportunity that you have, right? The only way that you can do differentiated manufacturing is you need a differentiated design. And so the fact is, and this is where, at Anduril, the recipe is how do we bring the best technology to the warfighter as fast as possible at completely different scales? That last part actually changes the product, right? Because if you're not solving for that scale on day one, you're just not going to be able to go do it. And so a number of the challenges of how are you thinking about your supply chain? How are you picking your components? How are you looking at these things? What are your supply base looks like? Depending on where the conflict is going to be, how would you stand that up? And so one of the big things from the automotive side is just understanding and seeing how that problem is solved at that scale globally allows you to look and basically say, okay, wait a second, here's the toolbox of solutions. Here's the things that we can pull on that to be able to go through it. And so like, that's one of the areas that it comes through. And then I think the other one is just, we need these capabilities right away. And within defense space, there's a tradition of like, hey, wait a second, I'm going to go do a prototype and see if I like the product. And then I'm going to go do some LRIP, and it's a complete redesign to go produce something at some low volume. And then I'm going to actually get to the thing, and I'm going to think about the full rate production, and it's a complete design spin again. And so then they start to do production, and you have all of these latent problems that are built up. One of the things that automotive does really well is like you are starting with the end in mind on day one. When they design the vehicle, you know the volume that you're building at, you know the thing you're doing, and you're using every step along the way to try to prove it out, that capability. And so like you look at some of the things we're deploying where it's like, hey, very early in prototypes, before we've even built a prototype, we are doing digital builds to find stuff to feed back to design while things are still malleable. We're actually thinking, okay, what's the rate that we have to build at? Okay, what's the process? As simple as it sounds, what's the work instruction? What's my cycle time? And we are testing against that when we're building the prototype to find out issues, such that you can burn down these issues as quickly as possible. And we'll never find 100%, but if you can find 60, 70% in this early phase, when you actually do want to scale it, you're not compounding all of these issues at the end. And it's something that, like automotive, on day one when you go into production, it's like in days you're expecting to hit full rate. And a lot of it is because you've pulled that all through your pre-production exercise. And so just another thing that we're looking at and kind of bringing that over.
I'd actually be curious to hear from, one of our two panelists that have worked for a more traditional prime, like the extent to which this actually differs from the way development has been done historically within the sector. Because it might not be appreciated by folks who work in kind of traditional manufacturing.
Yeah, I'll go ahead and jump in on that one. I think when we look at the legacy primes, manufacturing had often been kind of an afterthought, right? It's technology first, manufacturing second in terms of how we deliver. And certainly, some of the concepts here in terms of how we have to look at that problem differently based upon the threat. But with that, there was really never defined phases in the legacy prime environment, right? It just kind of shifted from prototypes to immediately delivering. And I think on the automotive side, right, you probably had more defined, here's our protos, we're going to go to EVMs, into PVMs, and then finally into mass production. And so never having that rigor in those frameworks has made it a struggle to be able to hit rates, all right? Because you're almost always building protos, it seems.
Just to build on that, I think the other thing that where we're seeing new defense come in, and I think the point you raised about attritable systems is such a mind shift change for where a lot of the traditional primes were. So when you think even about Lockheed, Boeing, Northrop, L3 designing and building products, you're of course designing needs for the warfighter, but part of your design, and it has to be, is also for how to get the program funded on the Hill. So a lot of things are, Lockheed was famous for having that congressional district map where they could point at an F-35 and say there is an F-35 job in every single congressional district in the country, and be able to tie that back to things. We're not going to have that when we're talking about attritable systems where the cost of these things isn't $100 million a pop every time. So rethinking of the architecture just in terms of that and multiple variants of these that can maybe supplant those jobs in a different way is a whole different mind shift change for how the primes now have to think about architecting their supply chain, what that means for manufacturing down the road as well.
Yeah, that's a great point. I think maybe sort of piggybacking off of that, what is for the various industries where you all sit, what is the frontier look like for MPI in production? Maybe starting with you, Keith. How do you find the manufacturing frontier at Anduril?
How do I define the manufacturing frontier? I think it's this framework of to the point where manufacturing is an afterthought. And I can understand it. When you're designing an exquisite system that you expect to last for 25 years, you want to add every little bit of technology you can because your next avenue is so long and far in the future. Where in attritable systems, it's different. We know we're going to refresh these on a higher rate. And so we're able to make trades between product performance and production performance in a way that hasn't traditionally been allowed, kind of like in the way that we have thought about platforms. And so like, how do you actually now go enable that through your process, right? Like for us, the frontier, and it seems as really silly, but it's like, we think of our factories and everything like a system of the product, right? And when you're building a plane, no one thinks twice about the fact that I can go design a structure, I can design a mechanical system, a fuel system, I can do the software system, all of this happens in parallel. And yet there's this view that the manufacturing is something like, okay, wait till the product's like 80% done and then go do it. The reality is if you don't have your manufacturing engineer and your sourcing engineer literally running side by side with your mechanical engineer, your electrical engineer, and your software engineer, like you are going to run into these things, like you're just going to box yourself into corners, right? And so the question is like, that's a change in process, right? Like it's a change in the way you do it. So how we develop manufacturing, when it's the tail end thing, people are very used to this waterfall. I'm going to go do it one time. It's going to be 80% right. Now we're getting more to like a design thing where if you look at a design today, everybody iterates. You're just continually iterating and iterating and iterating. How do you start to bring those tools, those processes into the manufacturing and the supply chain space where they traditionally haven't been done? Like you're usually looking for a situation where, okay, wait a second, I want to get this thing mature so I can just run it through the pipe smoothly. It's like, it's a completely different pipe if you're thinking about how you're going to iterate at this rate and this speed to go through that. And the things you find earlier and are able to feed back into design justify these spins. And so like a lot of the frontier is like, how do you set up those processes and then literally the tools that you provide the team, because it's a different way of approaching the problem.
Go for it.
So I think similar to what Keith said, the integration of manufacturing technology with product, how you integrate the performance of the product in the field and keep that in a closed loop regular basis is one of the most important things I see. So one of our customers is Beta Technologies, who people may know as a electric airplane company. And one of the biggest concerns when you're developing electric airplane is battery life cycle. So one of the things they've started to do is say, how do we measure every aspect of the battery from the point where we have the individual battery cell, where that gets installed into the actual battery component itself, who the mechanic is, who works on it, what the performance of the machine is at the time, as that cell gets installed on the airplane, how is it positioned, as the airplane flies, what is the data that's streaming off the battery, to show that anything that could potentially contribute to life degradation, how do they then make improvements in that standpoint? But it's a continuous flow from data from the point the battery is actually purchased, the components are purchased, to the point it's installed on the airplane, then the actual flight path itself. That technology and the use of that is I think, really revolutionized where we're seeing the integration of manufacturing and use.
For us, we put a constraint on ourselves, which is you have to be able to build the same product that comes off the production floor in the mobile production facility. And we force our engineers and our production team to work out of the Excels with everything they design. And so we have like unbelievably aggressive goals for what we want to take the product to in the next year. We almost want to be able to quadruple the output out of our mobile factory for our Group 2 platform. And when you put constraints on an engineering team, once they stop complaining, they will start actually figuring out how to solve the problem. Are we going to get to 4xing our production out of there? I don't know, but we think we're on our way to at least doubling it. And so that's been a big thing for us, in particular, like to the narrative of decentralized manufacturing. You have to be able to have the same product come out of the 20-foot container as it does the 70,000 square foot manufacturing floor.
I would say from my experience in legacy defense, I think we also, in order to enjoy that new frontier of NPI, is to start looking at investment and the availability of investment. Traditionally, all of the investment in defense has gone into the development of the technology, making the most cutting edge product that could possibly be delivered to the warfighter. And so, just not having the foundations in place, being able to get data, mine data, trust the data that you have in the factory, because we simply haven't put the systems in place. So, in my experience, it was trying to make the justifications, and then I have to tag on to what Keith had said in terms of moving towards concurrent design. Even if you don't expect to be able to provide all the changes or inputs from manufacturing engineer, to have them in the room, being able to see what's coming down the pike, and certainly going off and then positioning the manufacturing system to be able to support what's coming.
I think that's a good segue to my next question, which is around, surprise, surprise, AI. So you've been involved in frontier technology adoption at your time at L3Harris, and now, where have you seen the biggest wins from AI today, and where is the technology maybe not quite ready yet?
So admittedly, a lot of my investigation into new technology has been in AI ML vision. And those bounded problem sets is where I've seen AI most effective. Certainly, when we look at large data sets, whether that's parametric test data in the factory, is a source of where AI can come in and help uncover insights. But really, to sum it up, is when AI is being used as a tool. It's not going to be autopilot. And I've heard this a couple of times on the other panels. We're not at that point yet with the technology where we can just set it and forget it and let it solve system level problems. It needs to be bounded, and it's got to have some guardrails. Certainly in aerospace and defense, where regulation as well as assurance is paramount, right? So we can't accept errors or mistakes. Where it's probably not working quite yet, as I had pointed to, was at those unbounded problems. And when we don't have structured data available. And again, that's pretty rampant from what I've seen, is it's just not having the data systems in place for AI to come in and work effectively.
I'm curious if any of the other panelists have places where they're using AI within their manufacturing processes that might be interesting to share.
I'll throw a quick one out here. An unexpected massive market we've tapped into with our business is just-in-time part repair, okay? The DoD, we all could go get in a car right now and go buy a headlight at Pep Boys. The DoD does not have that option. We gave one of our XLs to the Navy. I got the report about 5 minutes before we stepped on stage. They said we delivered parts 5,000 times faster than their current supplier.
That's a great stat.
That is crazy. And
was in the deck.
I'm going to put that all over the internet. But what we're starting to play with is a bunch of technologies to empower an enlisted soldier to do part design in the field for when they break things. These soldiers are substantially more talented than we give them credit for. Not everyone can do CAD, right? But there's some things you can do with taking pictures or 3D guns. We're playing with about 5 different pieces of technology. We think that will enable that big unlock in the next couple years. Right now, they're making parts that look like goop, but we're getting better.
Tim, you've argued that IT won't lead the way on adopting new tech, that operational leaders really need to. Why is that? What kinds of organizations actually succeed in aligning technology adoption with mission outcomes?
Well, I mean, we've got 2 great examples up here of companies who are really leading the way in new technology. But I think maybe it's a little bit of a cliche to say business has to lead the strategy, but particularly on something like Gen AI, I think back to my days at Boeing, and I think this is true at any legacy company, maybe not just in A&D, but industrial manufacturing. When you are a junior engineer or a junior mechanic, one of the first things you're taught is, thou shalt not deviate from the process. The process will guide us. When you deviate from the process, you get a labor audit, you get a car. That's when everybody gets in trouble. So thou shalt not deviate in the process. And there's a command media book about yay high that tells you exactly what that process is. When you get into the world of things like Gen AI, it's completely about deviating from the process. It's creating new processes. You're actually doing things that we haven't thought of before. You're exploring with things that the company hasn't thought of and where they want to go before. So IT is not in a position where they can start to drive the business strategy that way. It has to be the business leadership. It has to be operations leadership for where the company wants to go, where they want to head, and what they want to define. And on the other side, even from a workforce standpoint, we've all seen the great opportunities with Gen AI, and we've all seen the concerns that people have about what's this mean for their job, what's this mean for their brand, and what's it mean for the rest of their lives. So you need the business leaders to be laying that strategy out for the workforce and where they see a future and where those things are going today. I mean, I was even thinking in a totally different industry today than we were talking about today. All these reports about Tilly Norwood that came out over the weekend. So if you don't know who Tilly Norwood is, she's a AI actress that just debuted at the Zurich Film Festival. And all of a sudden you had people saying Tilly Norwood is going to have a agent signed in the next couple of weeks. And you had this litany of Hollywood stars say, oh my gosh, this is going to destroy the industry. So if you're now the head of a studio, you have to think, well, there's some real opportunities by signing an AI actress, but also, what if I do that and my fleet of stars says I'll never work with the studio again? What are the definitions you're doing, and how do you think about what this means from your business strategy long term? IT is never going to be in a position to define that. They're going to be able to drive where they want to go, but it's the strategy that has to drive all those things. And then I think the last part of it is, because the technology is becoming less and less technical in a lot of ways, the end user, you talked about the soldier there who's designing parts. I remember back in Iraq when we had soldiers who were armoring up Humvees to create MRAPs, was essentially what they're doing there today. The democratization of this technology is such now that everybody is going to have access to it today. So business has to lead it from that perspective because it's just going to happen.
Yeah, one thing I would say on this, especially when you're developing new technologies, is like implicit in this is that you actually, at the start, don't know the best way forward, right? It is a new area, it's a new frontier, it's all these things that you're going into. And so this is why I think it's really key to tie it to business outcomes, and operators are doing this, because it's actually the technology in itself doesn't actually add the value. It is the impact on the business results that is actually driving the value. And so quite often where you'll see, and I've seen this a bunch of times, where like technology deployments are in IT, what they're trying to do is basically get the feature set up. Like, I want to actually go deploy this. But the reality is you need the operator, the person who actually wants to get the business result out, because you need that feedback loop. There's going to be times where you make a decision and you say, hey, I think this is great. And it's like, oh, wait a second, that's not achieving the result. I have to pivot. I have to make a change. And when you're deploying technology, if you don't have that, you get this great technology that ends up in a place that is actually not adding as much value to the business type thing. And this is why adoption in many cases is so hard, because it's like, yeah, it's great. It's just not doing something really useful or adding a ton of value. And so I do think one of the other elements of tying it to operators is the focus on the business result, not just the technology itself. And it's that feedback loop. I cannot underestimate how critical that feedback loop is in just telling you, is the thing you are doing right?
Maybe switching directions a little bit. You know, this is almost a yes or no question, which is sort of a faux pas for a moderator to ask a panel, but I'll ask it anyway. At the frontier, I'd be curious to get all of your opinions. Do you think the biggest innovation in defense is what is being built, or is it how it's being built? So, do you see the biggest innovation coming from, the drones or the new missile systems or the new technologies that are coming up right now, maybe with more AI and more intelligence at their core, or the processes, field factories, digital tools, et cetera, in their actual manufacturing? Maybe this will be a controversial question, but I'm curious to hear what you all think. Maybe you're biased because you're manufacturing people, but nonetheless.
I'll go ahead and take that one. So barring the implications of quantum and quantum computing and what its implications are going to be on the battlefield, I think that certainly is going to be very important. But when it comes to the traditional technologies, certainly the process of delivery is going to be the most important. And the way that I see this is, because we're moving away from exquisite hardware, we're going to have more differentiation in terms of the equipment that goes into the field, right? Single purpose, specific duty equipment versus it's got to do it all, right? It's got to meet all of these exquisite requirements. And so, as we get less complexity in these designs, it's going to be more focused on how quickly we can build them and deliver them to the field.
Anyone have a different opinion?
Build.
I don't think you can separate them, because you can't get one without the other. Like, the reality is like the problem is changing. We're seeing this from a small number of highly capable exquisite systems to an extremely high number systems where, either is not exquisite capability or exquisiteness is coming from software as opposed to hardware, right? And so like if I look at almost every meaningful change in the process of the build, it is actually enabled by an extremely creative design change that has allowed that to happen, right? And so like you don't get one without the other. And it's so like, how do you point your organization towards that outcome and let them, like your design engineer and your manufacturing, your supply chain team, work together towards that outcome? Because there's trades in this. Sometimes it's the design actually enables something else. Sometimes it's like, oh, wait a second, we have this opportunity on the build. Can you actually make the change in design, right? And you want your entire team looking at those opportunities, laying those out, and then doing what they need to do so that they get realized.
Yeah, I think this industry in particular, it's critical to always put yourself in the feet of the warfighter. And when you think about a question like this, somewhere out there, there's a Marine in a foxhole who you're building something for that person. And whether it's medevacing that person out, it's supporting them with air cover, helping them get out of a bad situation, ultimately that's your customer. So nothing will ever be more important than does the product do what it's intended to do. But you can't separate that from the fact that that Marine needs that product there at a particular time right now. They can't wait for 3 years for a development cycle to go through. So I think that anchoring your thoughts around this on who the warfighter is and who the user is kind of helps you center yourself into how you want to build the thing.
We're in a room with not all people who work in the defense industry. Historically, in the United States at least, the defense industry, well, maybe not for the last 30 years, but certainly before that, a lot of our success in defense industry was actually informed by the strength of our consumer industrial base. Like if you look at World War II, the reason why we were able to show up and kind of compete on a global stage as a third-rate power in World War II was because of the automotive assembly line, arguably. So consumer developments and kind of consumer hardware and manufacturing have always played a big role in the defense ecosystem in the United States. But maybe flipping that on its head a little bit, for the audience beyond defense who maybe work in consumer electronics or AI infrastructure, what's one lesson that we can take from the current frontier in defense, whether it's from Ukraine or what we're seeing emerge out of looming threat from China, like that they could apply in their businesses tomorrow or next year or...
How critical it is to think about the resiliency of your supply chain and the design of your products. It is, and it's just a different problem for us in terms of the fact that due to security and a number of reasons type thing, we think about the localization of our supply chain very different. But you just look at whether it be macroeconomic, national security, all of these things, and just having seen the disruptions we've had over the last years with COVID and stuff, and just understanding the lever you have within the design of your products to build up resiliency within your supply chain and just how critical that is.
Building on that, I'd say the embedding of security, meaning physical security, cybersecurity, data security, information security, into the product design itself, not as a separate layer or something that you would do elsewhere, but understanding detailed designs and for your supply chain of where your raw materials are coming from, how you embed that into things, how you protect data at every layer of those things, I think is something that we're going to see broadened out to energy grid, a whole rash of different things in the future as well.
I'll go really simple and high kind of, I guess, high vision here, but like everyone in the military is kind of given a list of tasks that they do as part of their rank, right? And when you introduce a new technology, if you disrupt what that person's going to do, you're going to have a really hard time with adoption. And so what we always try and do is like surprise and delight the user, in this case the soldier, by like making it as easy to use as possible. And I mean, that's kind of a universal rule for, I think, both defense and consumer.
Yeah, I think the one thing that always comes to mind for me is we've kind of moved to this consumable throwaway market, and the importance of design for reuse and repairability and how that factors into what we produce. As you said, these things need to be sustainable in the field. There's a concept of repair it yourself. And some of that doesn't really translate in the consumer market. And I think there's opportunities there to be able to get more out of the product that we're delivering.
And this is our last question, and I'd love to hear from all of you. This panel sits at the intersection of manufacturing, defense, and American dynamism. If we think about arsenal innovation as a national capability, who should lead the way? Is it startups? Is it primes? Is it the government? Would love to hear your thoughts.
Primes and startups working together. I think that's how you really move the needle, because the system's not going to change overnight. And so if primes are open to working with startups and pushing kind of new technologies or ideas through their channels, I think that's going to be the mega unlock for the whole industry.
Yeah, I think it's the whole ecosystem. And I think what we've seen recently, new defense is disrupting, and it's causing legacy defense to look at things different, challenging them to be more nimble. And then when you look at the government side, some gives, right? They came up with OTAs and different mechanisms by which we can contract and procure new technologies that didn't previously exist outside of program of records, being incredibly important to support innovation and delivering innovation to the warfighter. So it certainly is going to take everybody working together in concert, pushing one another further to really position us to be dominant in the battlefield.
Yeah, I think similar to what Dan said, in particular, the startups are probably always going to lead in terms of being on the bleeding edge of technology, but then the primes will help take that and take it to scale. And so that integration of saying, how do we take what's new and what's hot, what's capable, and instill it in a scalable model, I think is the only way things are going to go forward.
Yeah, I agree. It's going to take all three. I do think startups play a unique element in this, and the fact that their ability to reorganize and innovate and be able to do something different, especially at speed, is a critical. Like, it's a little bit like the spark. And so it's like, I look at my experience going from Toyota to Tesla and how hard it was for Toyota, as well as it did to reorganize or do something different, like getting over that institutional. And so kind of momentum. And so like both the government and primes that's just a difficult part of the problem. And so I do think that one of the things that startups bring to the equation is the ability that they do that very well. Like, it's in their very nature to pivot, to innovate, to like, oh, wait a second, how do I go do this differently? And oftentimes you need that spark to just initiate even what the opportunities are out there. But like, will not be able to do it unless the entire ecosystem is responding to that.
Great. With that, thank you all so much, and thanks to the team for having us.